Hello, everybody. So this is the video for Lab 11. So this lab, if you take a look at it, it's already open here, is just more stuff having to do with arrays. So we're mostly past arrays now in lecture, but so you'll want to go and look at the week 10 lectures or maybe even the lecture 1 from week 11 for more information about this. With that said, we'll just kind of jump right in. So let's read it. So Lab 11. Write a Java program called Lab 11 Problem 1 that does this. So what's it say? So store myArray 0 in a variable, max value, use a for loop to loop through the remaining elements of the array and update the value max value if the current array is larger than the max. After the loop, print a message that we found the maximum. This is the general steps to find the maximum in an array. Now, if you look at problem 2, it's the same thing, but it is looking for a minimum value. Problem 3 is asking for us to add up all of the values of an array. And problem 4 is asking us to find the average of the elements in an array. Now, if I go home and we look here, then I think that this lecture 11 arrays 3 here is not going to have what I want in it. Actually, hold on one second. I'm going to hit pause and then unpause. Oh, I didn't pause the thing. Okay, how do I unpause it? Resume? I don't know what that looked like to you guys. Hopefully it's not bad. Uh, anyway, that wasn't very long. What are we doing? So I want to download this Arrays 3. I'll download it and we'll open it up. And here we go. Now, if you look in here, this is talking about two-dimensional arrays and enhanced for loops for arrays. And that is not what this lab is about. So you'll need to go look for the first two lectures on arrays, which are actually going to be available in the previous week, week 10. So if I do go to week 10 in the modules, click on here, scroll down, and we have arrays part 1, and then lecture 2 covers, it says lecture 10 arrays 2, and it says more arrays, min, max, averages, etc. And so that's exactly what we're talking about in this lab. And so if you open up this set of lecture slides and we scroll through it, sum of an entries of an array, that's one of the problems. Average of an array, that's one of the problems on the lab. Um, Maximum and minimums, those are two other problems in the lab. Okay, so all of the code that you need actually is in here, so you don't even really need to write it yourself. So because of that, I'll do this relatively quickly, and we'll just do it all in one lab. So if I have Eclipse open, we'll create a new project, and I'll just call it Lab 11. And then I will open up our source folder, add a class. We'll just call that Lab 11. I'm going to put them all in this one single um, class file rather than having separate Java files for every part. So we have a blank file here. Now let's look here in a little more detail. And our lab, which is here. So the array is 281439586. 2814395. Like it looks like the same array every time. So we can actually just kind of take that array. I guess I should take it from the first one. Get the array from problem 1 and we'll put it into Eclipse and we'll be using that array the whole time. Spacing's weird here. That's just how it's typed. All right, so we'll be using that array the entire time. Then this first problem is going to have us find the maximum of an array. And the instructions here, like the steps it says to use, are the steps that we're going to follow, but I'm not going to keep reading them. So I'll just put problem 1, find max. So the way to find the maximum of an array is you start out by taking your variable that you're going to store the maximum in, and you put the first element of the array into it. So that's just my array 0. That's the first array entry. So it'll be a 2. Okay. The second step is to loop through the entire array. Now you can use the enhanced for loops, or you can just use the regular for loops. Now, when we're looping through an array, you start your counter at 0. You do I less than my array dot length. That will make I go to the last entry, which will be the length minus 1. And then we do I plus plus. So we add 1 to I every time through the loop. Then in here, and again, the problem will tell us this, what we need to do is we need to compare the current entry of the array, which is going to be my array subscript I. We need to see if that happens to be bigger than what we think the maximum is. So this value, max value, is going to store first entry of the array. And then as we loop through the array, we're going to be comparing the current maximum, which is going to be 2, to whatever the current entry of the array is. And in the loop, the current entry of the array will be my array I. So we'll compare the 2 to an 8. And since the 8 is bigger, 8 will be our new maximum. Then we keep going until we find something bigger than the 8. We'll find the 9. And then because the 9 will be bigger than the max value, we'll update the max value to be 9. And then finish out looking through the array. So what we need to do is if the current entry of the array is ever bigger than the maximum value, then that means that the current entry of the array is the maximum value. So we just do max value equals my array subscript I, like that. Uh, should be a semicolon there. I accidentally hit quote. All right, so there we go. So this code here, that's just how you find a maximum. At the end of the day, what are we supposed to do with it? I'm just kind of smushing it all together here for conciseness. And then it says in our lab, after we find the maximum, we should just print it out something like this. So we should do a system.out.println. And you don't just print the max value is 9, even though it is. You print the max value is, and then we will fill in the actual max value like that. So when we run this, it says the max value is 9, which it is. Cool. Now, the next problem is exactly the same thing, except we should be finding a minimum, I believe. So what's the difference? Well, first of all, we should rename our variable, right? It shouldn't be max value, it should be min value. After we rename the variable, we still want to store the first element of the array as the minimum. We still want to loop through every element of our array. But this time, we're not looking to see if the elements in the array are bigger than the max value. We want to see if the element in the array is less than the minimum value. If it is, it's our new minimum. And that's it. So we change this less than, we change the greater than to a less than, and we change the word max to min everywhere. And that's all we needed to do. So when we run this now, it says the max value is 9, the max value is 1, because I forgot to change this text. So the max value is 9 and the min value is 1. Cool. Then we move on to problem 3. Problem 3 is same thing, but we're adding up everything in the array. So we'll copy our entire code again. Problem 3, sum of array. So we need a variable for that. So I'll call it array sum. We don't need to read the first element from the array anymore. What we do need to do is loop through our entire array. And what we do is we just take the array sum, which is going to start out as 0, And we just need to add on whatever the current entry of the array is. So as I said, we need to start that at 0. So we need our array sum to start out at 0. And then as we go, we're just going to add the current entry from the array onto the array sum. And when we're done, we can say the sum of the array is array sum. Let's see what it does. Sum of the array is 46. Seems plausible. Cool. Lastly, we want to, what do we want to do? We want to find the average of the array. So the average of these numbers. So we don't actually need another loop for that, although if we started the problem in its own class, we would do everything that we did for the sum. But since we're just continuing on here for problem 4, average value of the array, all we need to do is calculate the average value. So we need a variable to store it, which will be a double because we expect to get, fractions. Give it a name. I'm sure it says a name here, like it says array average, but we'll use theirs, I guess. Oops. Oh, come on. Just let me just highlight that. Okay, there we go. So we have our average there. And then to actually compute the average, all we need to do is we need to take the sum, which we have from the previous part, array sum, and then we just need to divide it by how many entries are there in the array, which is simply my array dot length. So this is the sum of the array divided by the number of entries in the array. That will be the average. There's a little bit of a bug here, which is that if we're not careful, we will do an integer divided by an integer here, and that will be an integer value, which means we won't get a fraction. So I have to actually typecast here and add this double in front of array sum just so that it will treat the array sum as a double and it'll do floating point arithmetic here instead of integer arithmetic here. And with that said, we just need to print out our answer. So I'll copy out a print statement and we'll just say the average value of the array is, and we'll change this to array AVG for average, run this, and there we go. So average is 5 point lots of ones. Cool. So that's it. Those were the 4 parts of the lab. So pretty short and sweet. And that's what we need to turn in. So we should submit the code as one or more Java files, and we should also screenshot it showing that our code runs properly, which would just show, this sort of stuff here. All right, that's it for this week's lab. I will talk to you guys later.